2002 Canadian Open Mathematics Challenge, Part A. In triangle PQR, F is the point on QR, so that PF is perpendicular to QR. If PR is 13, RF is 5, and FQ is 9, what is the perimeter of triangle PQR? Let's label this. They are saying that PR is 13. Well, it's already labeled. RF is already labeled. FQ is 9. That's labeled also. So the first step, I think, will be try to figure out PF, this distance right here. And we can do that pretty easily with Pythagoras. PF squared plus 5 squared is equal to 13 squared. So PF will be equal to 12 when you do that math. So let's label that there. Our next step will be to figure out PQ, which can be done with Pythagoras as well. 12 squared plus 9 squared is PQ squared, and therefore PQ will give you a value of 15. So put that there, 15. And now I think we are ready to figure out the perimeter of triangle PQR. So that perimeter, P for perimeter, is 15 plus 9 plus 5 plus 13, and that is 42. If x plus y is 4 and x times y is negative 12, what is the value of x squared plus 5xy plus y squared? These types of algebra questions involve some simple manipulation, and if you've done enough of them, you can recognize it pretty quickly. X plus y, if I square it, is x squared plus 2xy plus y squared. Correct? Now, if I just put x squared plus y squared on this side and then throw the 2xy on the other side, it becomes x plus y squared minus 2xy. Now, the reason I did this is because we have been given the value of this and the value of this. X plus y is 4, xy is minus 12. So I can substitute that in here. 4 for x plus y and minus 12 for x times y is equal to x squared plus y squared, because this guy is in here. So if I can get that value, it will help me. So this is 16, this is positive 24, and therefore x squared plus y squared has a value of 40. So now we go back to this guy, which is x squared plus 5xy plus y squared. Well, x squared plus y squared is 40. And then we have this 5xy. xy is negative 12. So there we go. So that becomes 40 minus 60, and that is negative 20. A regular pentagon is a 5-sided figure which has all of its angles equal and all of its side lengths equal. In the diagram, trend is a regular pentagon, PEA is an equilateral triangle, and open is a square. Determine the angle size of EAR. All right, so where is EAR? It is here, EAR right here. So we'll just call that theta right there. Okay, so that's what we have to figure out. Okay, well, some of this stuff is pretty straightforward. If this is a square, these are all right angles, 90 degrees. If this is an equilateral triangle, PEA, then those are 60 degrees. So 60, 60, and 60. And then, let's see, what else can we do here? Well, we are told that this is a square, so all of these sides are the same. And we are told that this pentagon, all the sides are the same. So that means all the sides are the same as EN. If this is one side and all the other sides are the same, then that means all the other sides are the same. And then since this is an equilateral triangle, all the sides are the same as PE. So therefore that's the same as this. So that makes me conclude that this is isosceles, that triangle AER. So if that's isosceles, then this is also theta right here. Got it? And therefore, all I really have to do is figure out this angle, and then I'll be able to figure out that theta. Now, this angle in here, which is an interior angle of the Pentagon, some of you already know what that measure is. Even if you didn't, you can notice that a pentagon is really 3 triangles. And because it's 3 triangles, the sum of the interior angles must add up to 3 times 180. And how many interior angles are there? 1, 2, 3, 4, 5. So 5, we'll just call it alpha. We'll say each of these is alpha. Okay, so that means 540 is equal to 5 alpha, and therefore alpha is 108. So there you go. This angle in here is 108. So we have everything to figure out this angle, which I'll call x. All the angles all the way around will add up to 360. So x plus 108 plus 90, because that's the right angle, plus 60 will be equal to 360. And if you do this math, you get x equal to 102. All right, great. So now we can concentrate on that triangle and figure out our theta. Theta plus x plus theta is equal to 180. That means 2 theta plus x is 102, is 180. And therefore 2 theta is equal to 78. And theta is equal to 39 degrees. So EAR is equal to 39. In the sequence of numbers, the sum of the first n terms is equal to 5n squared plus 6n. What is the sum of the third, fourth, and fifth terms in the original sequence? All right, so we've got a1 plus a2 plus a3 plus a4 plus a5 and so on, right? It just keeps on going all the way until we get to the last term, which is an. And they're saying that is equal to 5n squared plus 6n. And they want you to figure out the sum of the third, fourth, and fifth, just these guys. Okay, I think I can do that. a1 plus a2 plus a3 plus a4 plus a5, just those first 5 terms, that would mean n is 5, using this formula, would be equal to 5n squared, which is 5, plus 6 times n, which is 5. So that's what, 25 times 5, which is what, 125 plus 5, so 125, sorry, I forgot the 6 there, plus 30, so 155. All right, great. Now, I will use n equals 2 to figure out a1 plus a2. And that is going to be 5 times 2 squared plus 6 times 2, and that is 20 plus 12, which is 32. So just to get those 3 guys, it looks like I have to subtract from here these 2. So that means a3 plus a4 plus a5 is a1 plus a2 plus a3 plus a4 plus a5 minus that a1 plus a2, correct? So the first sum was 155. These 2 added together we calculated as 32, and therefore that is 123, the answer to this question. If m and n are non-negative integers with m less than n, we define m symbol n to be the sum of the integers from m to n, including m and n. For example, 5 symbol 8 is 5 plus 6 plus 7 plus 8, which is 26. For every positive integer a, the numerical value of 2a minus 1 symbol 2a plus 1 all over a minus 1 symbol a plus 1 is the same. Determine that value. Okay, so this shouldn't be too hard. 2a minus 1, the symbol 2a plus 1, and then the all over a minus 1, the symbol of a plus 1. So we've got to add everything from this number to that number. Okay, so first we're going to go do 2a minus 1, so every integer. So the next integer is 2a, because you're adding 1. The next integer is 2a plus 1, and we don't need to go any further because that's there. On the bottom, a minus 1, then add 1, so that would be a, and then add 1, a plus 1, and then that's it. So on the top, it looks like we have 6a, and on the bottom, we have 3a. The a's cancel, and then we just get 2. That's it. Two mirrors meet at an angle of 30 degrees at the point V. A beam of light from source S travels parallel to one mirror and strikes the other mirror at point A, as shown. After a number of reflections, the beam comes back to S. If SA and AV are both 1 meter in length, determine the total distance traveled by the beam. So SA and AV are 1 meter. Okay, so this diagram, we're going to need to blow it up. I think that should be sufficient. Okay, so my first question is, what is this angle right here? Well, they told me that this is parallel to this, correct? SA, let's go back. A beam of light from S travels parallel to one mirror. So this is the mirror that it travels parallel to. So that's important to remember. So therefore, based on our angle rules, this angle will be the same as that angle. So this is 30 degrees. Now, once the beam of light travels to A, it bounces off like that, right? So my next question is, what's this angle? And that, I don't know if that's obvious to most people. It has to do with angle of incidence and angle of reflection. So this angle in here is known as angle of incidence. Angle of incidence. This angle right here, the 30 degrees. And then when it bounces off, this angle here, whatever that angle is known as angle of reflection. And the good news is that the angle of incidence is equal to the angle of reflection. So if that was 30 degrees here, this is going to be 30 degrees there. Okay, so that's just how it is. And then what you have to do is you have to extend that line, which they have drawn part of it, right? So we're going to extend it all the way to the end there. Okay. And before I keep going, let's go back and start talking about the angles again. If this is 30 and this is 30, then what's this angle in here? Well, all the angles about a line are equal to 180. So that means that angle in here must be 180 minus 30, which is 120. So this goes at 120. And then supplementary angles, if you remember, if you have two lines that are parallel, this angle and this angle are known as supplementary angles. So what that means is that they both add up to 180. A plus B are equal to 180. Supplementary angles. Supplementary angles. So since we have one guy is 120, this must be 60. Correct? So there's no tricks there. This 30, by the way, is this angle right here. It's so big that kind of might be a little confusing. Okay, so let's keep going here. Now, this thing is going to bounce off here and go in some direction, right? We don't know which direction it's going to go. But we know the angle of incidence, which is right here. This is the angle of incidence. And therefore, when it bounces off, let's say it bounces off and goes, well, obviously it's going to go to AV. So let's say it goes here like that. The angle of reflection has to be the same as the angle of incidence. So that's the angle of incidence. So the angle of reflection, which is right here, that also has to be 60 degrees. So I'll just put that in there, is 60 degrees. Okay? All right, so far so good. Now, this was 30, It's huge. It's written huge. I'm just going to write a small 30 in there. And this is 60. So that means that this is 90. Okay, great. Now, that's very interesting because if that's 90, then that means that the angle of incidence is 90. And therefore, the angle of reflection will also be 90. And what that really means is that it's going to bounce back. Right? So if the beam travels like this, it eventually bounces back and travels back. So it goes back like that. Eventually just will go back. So all we have to do is figure out the length of this path and then double it to figure out the length of the total path. I think that's good enough. Okay. So we have to figure out SA plus, well, let's just label this B here. And we'll label this C. Why not? SA plus AB plus BC. And then at the end we have to multiply it by 2 because it's going back to S eventually. All right. That should be all we need to do. Okay, here we go. Well, SA is the easiest one. That's 1. But then now we have to figure out AB and BC. All right, take a good look here at AVB, that triangle right there. You'll notice it's isosceles. How do I know that? Because that angle is the same as that angle. So that means that this is the same as that. Okay? And also, since this is a perpendicular, BC, in an isosceles triangle, the perpendicular will cut the other half, will cut the other side into half. So if this is 1, that means this is a half, and then this is a half, like that. So this A to C is a half, and then this C to V is also a half. Okay, so now we can use 30, 60, 90 triangles, since this angle in here is 60, and this is a right angle, to figure out the lengths of A, B, and BC. Okay, so this BCV, I'll just draw it over here, avoid making the diagram so messy. So we got B, C, and V. BC and V. We concluded that that's 1/2. And for the umpteenth time on a math contest, we've got a 30, 60, 90 triangle. And as always, the ratio of the sides are 1, 2, and √3. Correct? So that means that BC over a half is the same as 1 over √3. So BC is essentially equal to 1 over 2√3. Yeah. Okay. So I can substitute that in there. 2 times 1 plus AB, which I will find very soon. There we go. And then now we have to calculate AB. AB we can get, again, pretty quickly. I'll put that triangle over here, the ABC triangle. So we've got this right angle. This is A. This is B. This is C. This is 60 degrees, this is 30, and the ratio of the sides are 1, 2, and √3. And we know that this is a half, the actual length. So that means that AB over a half is the same as 2 over √3. So that means that AB is equal to 1 over √3. So put that in here, 1 over √3. Okay, so this looks like it'll be 2 plus 2 over √3 plus 2 over 2 √3. And that's pretty much the right answer. If we add the fractions here, multiply top and bottom by 2, it'll be 2 plus 6 over 2 √3, which is 2 plus 3 over √3, which is 2 plus √3. Yep, that's the answer. So that basically is the total distance traveled by that light in that beam. We go back to the original question. What are they calling it? The total distance traveled by the beam. The beam of light, I guess. Yeah, beam of light. N is a 5-digit positive integer. A 6-digit integer p is constructed by placing a 1 at the right hand of n. A second 6-digit integer q is constructed by placing a 1 at the left hand end of n. If p is 3 times q, determine the value of n. We have a 5-digit integer. We'll call it A, B, C, D, E. These are the digits. And then they're saying that if you stick a 1 at the end on the right side, that becomes p, a new integer. And then if you stick a 1 at the left side, then this 6-digit integer is q. And then this original one is n. Yeah. And they have told me that p is equal to 3 times q. So, and then I have to figure out the value of n, find n. Okay. Well, some of you know this, but some of you don't. But let's say you have a number 27104. And I say, what is this number? Write it out. Well, it's 2 times 10,000, right? Or 100,000. Yeah, 100,000, because this is 1, 10, 100,000, 10,000. 10,000, yeah. So 2 times 10,000 plus 7 times 1,000 plus 1 times 100 plus 0 times 10 plus 4. And that will give you the 20,000, 7,104, and then you add it up. So the same sort of principle will apply to P and Q. So P, if you look at that's a 6-digit, so it'll be A times 100,000 this time. So it'll be 100,000 A plus 10,000 B plus 1,000 C plus 100 D plus 10 E plus that 1. And then Q starts with 1. Right, let me just write out what P was. It was A, B, C, D, E, 1. That was the actual number. Q is 1, A, B, C, D, E. So that will be 1 times 100,000, which is 100,000. And then, oops, one more 0, I think. Yep. And then A times 10,000, so 10,000 A. Plus B times 1,000, so 1,000 B. Plus C times 100, so 100 C. Plus 10 times D. And then that E at the end. And then we utilize this formula that they gave us in the question. So P is equal to 3Q. So this P, oh boy, write it all out. So P is equal to 3Q. So you do that. All right. Okay, so then we have to do some algebra with this equation here. If you put everything on one side, let's see here, this 1 and this 300,000, that makes 299,999. Collecting like terms, basically. This 100,000 and this 30,000 will become minus 70,000 A, and you get the point. Plus 10,000 plus 3,000. If you put everything on one side, this becomes minus 7,000 B. And then similarly, 700 C, 70 D plus 7 E. And there we go. Now I'm going to put all the negatives on one side. So I'm going to stick the 299,999 on one side, and everything else goes on the other side. So 70,000 A plus 7,000 B plus 700 C plus 70 D plus 7E. If I factor out a 7, I will be back to my 10,000, 1,000, that kind of story. 1,000 plus 100 C plus 10D plus E. And then if I factor out a 7 here, I get 42857. And then drop the 7 from both sides, and you'll notice that this is equal to that. So that means that A, B, C, D, E written in digits is 42857. So pretty cool, right? It's a good question. Suppose that m is an integer with the property that if x is randomly chosen from the set 1, 2, 3 all the way up to 999,000, the probability that x is a divisor of m is 1 over 100. If m is less than or equal to 1,000, determine the maximum possible value of m. Before I tackle this question, let's explain what's happening. What are they talking about in this question? I'll give you an example. Let's say m is equal to 500, right? M is less than or equal to 1,000, so we can choose any number that's less than or equal to 1,000 to explain what this question is referring to. Now, what I'm going to do is break up that 500 into its prime factors. So 500 is what? 2 times 2 times 5 times 5 times 5, I believe. So that's basically 2 to the power of 2 times 5 to the power of 3. Now, we don't need to list all the factors, but I will. I think 1, 2, 4, 5, 10, 20, 25, 50, 100, 125, 250, and 500. So how many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 factors. But I did that manually, meaning I wrote them all out. Now, you really don't want to do it manually, right? That's a real pain. So the good news is there's a quick way of figuring out how many factors does a number have. All you have to do is take this. So in this case, it's 2, add 1 to it. Then take this exponent, which is 3 in our case, add 1 to it, and then multiply them. So that's 3 times 4, which is 12. I manually got 12 here, but I really quickly got 12 here. So obviously you want to do it the quick way, because it could be 2 to the power of 17 times 3 to the power of 12, and you're obviously not going to write out all the factors, because that would take forever. So that is the first part. There's 12 factors to that number. Now what they're asking for is you now have to dip into this set and extract each of these guys. You got to take out the 1, you got to take out the 2, the 4, the 5, so on, right? So I'm going to take out 12 numbers from this set. If I take out 12 numbers from the set, how many numbers are in the set? Well, it looks like there's 1,000 numbers. That is the probability that x is a divisor of m. So this is the probability that a number, a randomly chosen number, x, is a divisor of m. So I hope that makes sense. Now, 12 over 1,000, whatever that is in lowest terms, it doesn't really matter. But 12 over 1,000 is not 1 over 100, right? So we have to figure out a scenario where this number is 1 over 100. Correct? So what that means, basically, that this number has got to be a 10. Because if the probability is 10 over 1,000, that is 1 over 100. Correct? So if I can find an m that breaks up into a prime factorization that leads me to get a 10 for the number of its factors, I will have solved the question. But they also make it a little bit harder. They say want the maximum value of m. So the closest we can possibly get to 1,000. Okay, I don't think that should be too bad. So let's work with this and see what we get. Let's start with 1,000, which is the absolute maximum value of m. And when you break it up into its prime factors, it's 2 to the power of 3 times 5 to the power of 3. And then number of factors, we use, of course, our shortcut. And that would be 3 plus 1 times 3 plus 1, which is 16. Okay, well, 16 obviously is not 10. Our goal is to find a number that has 10 prime factors, because if you take 10 and put it over 1,000, you will get 1 over 100, which is what they want. Okay, not a problem. We'll just keep going. It's not a big deal if we are incorrect in our first attempt. Let's try m equals 999, which is the next integer down. This is 3 to the power of 3 times 37 to the power of 1, because 37 is a prime number. Number of factors would be 3 plus 1 times 1 plus 1, which is 4 times 2, which is 8. Okay, we don't have 10, but you keep going. Let's try another one. So the next one is 998. And that is 2 times 499, because 499 is a prime number. So the number of factors would be 1 plus 1 times 1 plus 1, which is 4. Okay, still don't have 10. And then you keep going like this, right? So eventually, you get down to 976. And that is 2 to the power of 4 times 61 to the power of 1. Its number of prime factors, 4 plus 1 times 1 plus 1. 5 times 2 is 10. There you go. And this is the first time as you go down this list that you'll get a number that has 10 prime factors. If it has 10 prime factors, then it would be 10 over 1,000 with regard to the number you would take out of the set divided by the total number in the set. And that, of course, reduces to 1 over 100, and you will have satisfied the question. Okay. Now, I know exactly what you're thinking. You're thinking, great, but do I really have to go through this? And it's going to take a long time. 997, 996, 995, and so on. Well, the good news is you don't have to do it that long way. There's a shortcut. And the shortcut really emphasizes the fact of what I did just right here, what I've been doing over here in this part of the question, which is I want to get 10, right? That's basically all I care about. So how do I get 10? Well, m is going to be equal to something to the power of something times some other number to the power of some other number. Actually, m is not probably the best letter to use. Let's just call them whatever you want to call them. Small a and small b, I guess. Okay, so basically to get the number of factors, you were doing a plus 1 times b plus 1. And that has to equal 10, correct? So that's what we have to fiddle around with. And that hopefully will be a little bit quicker than this big long system of trying to go through each number one at a time. Okay, so we want this kind of scenario. So how do I get 10? Well, there's several ways of getting 10. There's, 2 times 5. That's one way of getting 10, 2 times 5. So if that's the case, then A would have to be 1 and B would have to be 4, right? Okay. So that means my number is something to the power of 1 times something to the power of 4. And now let's see what kind of numbers I can put in for A and B to get it as close to 1,000 as possible. All right. Now, recall when you break up a number into its prime factors, the numbers, the smallest number that it could possibly be is 2. You can't put 1 because 1 is not a prime. So let's say I will start with the smallest. B is 2. If B is 2, then we have a to the power of 1, 2 to the power of 4. So 2 to the power of 4 is what? 16. So essentially I've got 16a. Now, I want my 16a to be as close to 1,000 as possible. So 1,000 divided by 16 is 62.5. Okay, so let's say a is 62. It's got to be an integer. So m is equal to 16 times 62. And that, let's see if that works. Let's see what happens. If m is equal to 16 times 62, if I break this back into its prime factors, it becomes 2 to the power of 5 times 31 to the power of 1. The number of factors, therefore, would be 5 plus 1, and then 1 plus 1, which is 6 times 2, which is 12. Okay, that whole thing fell apart. Okay, not a problem. That's what trial and error is all about. Instead of 1,000 divided by 16 and then using 62, let's try the next one over, which is 61. So m is 16 times 61. Let's see what happens. 61 is a prime number, so this is just going to be 2 to the power of 4 times 61 to the power of 1. Number of factors would be 4 plus 1 times 1 plus 1, which is 5 times 2, which is 10. There we go. So therefore, 10 over 1,000 is our probability, and that is 1 over 100. So I think this is probably a little bit quicker than the other system of going through every number, 1,999, and so on. It's a good question. It's a very, very well-written question, and I encourage you to practice this system that I've described here.